Good morning, student. Since in the derivation of the physical meaning of curl of a vector field, we have used the notation of line integral as well as the surface integral. So it's a hard time. It's a time we should discuss about these topics rigorously. Today, let's start the class with the discussion on line integral. Okay, as the name suggests, in the line integral we have to do the integration of a field. It may be either a vector field or a scalar field along a path. Okay, this path may be open or may be closed. If it is an open integral, then it's known as the open line integral, and if it is a closed one, then it is known basically as the closed integral. For example, suppose the path is like that, a to b, and if you do a integration of a scalar or a vector field along this path, then this is known as the open line integral. But if the path is like that, so the starting and ending point are the same, and this kind of line integral will be known as the closed line integral, and it's represented by this symbol. Okay, so as the vector and scalar field, for both type of field, line integral is possible. Therefore basically we can define three types of line integral. The first one is line integral phi dr. Okay, here dr is a vector because we have to do the integration along a certain path. The path should have a direction. Therefore this dr is a vector field, and say a to b. Here the integration is from a to b. So this is first type of line integration. Okay, the second type of line integration we can define as, say, a to b, a dot dr. Here a is a vector field, and we are taking the line integration from a to b. Okay, so a dot dr, this is the second type of line integration. Okay, and now the vector product is also possible. The cross product is also possible between two vector. Therefore the third type of line integration could be a to b, a vector cross dr vector. This line integration is also possible. Okay, so basically let me discuss the physical meaning of this line integral a to b, a dot dr. Okay, suppose a to b is a part here, a to b. So there is a vector field exists in this region. Say this vector field is a. This is a vector field a. Okay, so this is a vector field a, as I have mentioned here. Now the meaning of a dot dr is that what we have to do, we have to divide the interval from a to b into, say, n numbers of small parts. Okay, we have to divide a to b distance into n number of small segments. Okay, so let's say the thickness of each such segment is delta rp. So this thickness is nothing but delta rp. So if n tends to infinity, then delta rp tends to 0. This is obvious case, because if the number of segments increases, then their thickness will decrease. Therefore I have written that n tends to infinity, delta rp tends to 0. Okay, now consider a point at center of this small line segment, and so the coordinate of the point we can define as xp, yp and zp. Okay, this is the coordinate of the point which we consider at the center of this line segment having a thickness delta rp. Okay, xp, yp and zp. This is a, say, three-dimensional vector. Therefore we have considered x, y, z coordinate system of that particular vector field. Okay, then the value of the line integral a to b will be equal to a dot dr will be equal to limit n tends to infinity, because we have divided into n segment. Now we have to sum up all the segments. Okay, each segment having thickness rp. Okay, and there is a dot dr. That means we have to do something like that. So P is equal to 1 to n, because for single point it is xp, yp, zp. There can, since there are n segment and there can be n numbers of points possible. That's why I have written P can be start from 1 to n. Okay, so we have to find the value of the vector field A at each point xp, yp, zp. Okay, A dot dr meaning is we have to find the value of the vector field at each point xp, yp, and zp. Okay, delta product or dot product into delta rp. Okay, so this is the physical this is the meaning of the line integration from A to B, A dot dr. Okay, so the let me repeat it again. The meaning of A to B, A dot dr, what we have to do, we have to divide the whole path A to B into n segment. Then we have to consider a single point in each segment. Suppose we have considered a point at the center of the segment, and we let n tends to infinity, so that the number of segment is very high. Therefore, delta rp tends to 0. Okay, so then we can define the line integral from A to B, A dot del r as equal to limit n tends to infinity, summation of p is equal to 1. We have to find the value of the vector field at each point A, xp, yp, and zp, and we have to do the dot product of this vector field with delta rp vector. Okay, and this sum up is this summation is known as the line integration of A to B, A dot dr. So this is the mathematical definition of the line integral of a vector field. Okay, so similarly now we can define the other product also. For example, A to B phi dr, then we have to define the value of the scalar field at each point xp, yp, and zp, and we have to do the ordinary product of phi xp, yp, zp with delta rp. Okay, so that will give us the value of the line integration for this scalar field. And similarly, in order to find the meaning of this line integration A cross dr, what we have to do, similar technique we have to apply, but now this dot product would be replaced by cross product between the value of the vector field at each point xp, yp, zp cross delta rp. In this similar fashion, we can define the line integral of various scalar and various vector field. Okay, so this is the mathematical treatment of line integral. Okay, but when we are going to do the calculation, you can see we are hardly going to use this concept. It is very difficult to it's very easy to carry out the line integral, which you can see once we do some once I show you some examples of line integration, how to carry out the line integration. Okay, so I hope this is now clear. Now let me define the first type of integral, phi A to B phi dr, in a more general case, not the mathematical definition, but a general statement of this kind of a product. Okay, here phi is a scalar field. Remember, phi is a scalar field. Okay, and dr is nothing but the increment of a position vector, so it's a vector quantity. So dr, since r is equal to we know x into I cap plus y into j cap plus z into k cap, therefore dr will be equal to dx into I cap plus dy into j cap plus dz into k cap. Okay, so therefore A dot B phi dr vector will be equal to say phi will be a scalar quantity, so it doesn't have any component along any axis. It's a number basically. Therefore we can write the first will be equal to I cap integration A to B phi dx. Okay, so this is the first definition, plus second component will be equal to A to B phi dy plus k cap A to B phi dz. Okay. Now since a to b it's not a closed one, say a to b it's not a closed integration, say this part we have named it as c is a part, so we can write it basically I cap c phi into dx plus j cap c phi into dy plus k cap c phi into dz. Okay, so this is our the more general definition. Okay, the general definition of the first line integral. Well, secondly, if we find out if I write the second general definition of this quantity a dot b a dot dr, then what value it will have. Okay, so since a is a vector field, now a is a vector field, so we can write a as a1 into I cap, a1 is the component along x-axis, a2 into j cap plus a3 into k cap. Okay, so the product between two vector field vector quantity is a scalar quantity. Here the final outcome will be a vector because it's a ordinary product of scalar field with a vector quantity. Okay, now this is both are vector quantity, therefore this product will be basically a scalar quantity. All right, dr we can write as always dx I cap plus dy j cap plus dz into k cap. Therefore c a to b I have written it as c a dot dr. What will be its value? a1 into dx c I dot I is equal to 1 and other will be 0, so I am basically not going to consider the other product. Okay, c then a2 dy plus c a3 dz. Sorry. So this is the definition of the general definition of a dot dr. Okay, the line integration between the line integration of a vector field. Okay, so a1 dx plus a2 dy plus a3 dz. Okay. So but in similar way we can define the line integration for the other quantity also. For example, if I write it explicitly, then the third quantity was how much? Let's see, a cross dr. Okay, so here it will be, after all it will be a vector quantity. So if now first let simplify this expression, say I, j and k. So this is a1 a2 a3 dx dy dz, right? So I cap will be equal to a2 dz minus a3 dy. Okay, so this basically plus j cap will be equal to a3 dx minus a1 dz plus k cap will be basically how much? a1 dy minus a2 dx. Okay, so this is the product of a cross dr. Okay, so now the line integration will be it will be a vector quantity basically, because this is two vector. Therefore the value of the line integration c a cross dr will be equal to I cap, so c a2 dz minus a3 dy. Okay, plus dot dot dot. I hope you understand what is the rest of the meaning. Okay, so in this way we can define the line integration of a scalar as well as a vector field. So only three types of line integral is possible: the ordinary product of scalar field with the line element, dr is known as the line element, and it's a vector quantity, because in line integration we always have to know what is the path or what is the path. Okay, and second line integration is a dot dr. This will be always a scalar quantity, and third line integration will be a cross dr. Again it will be a vector quantity because it involves the vector cross product of the vector with the line element. Okay, so in this way we can define the line integration of a scalar or vector field. Okay. So before ending up this part, let me discuss a little bit some properties of a line integration. For example, we have a path like a to b. and if we consider a point in between the two end point A and B, then the line integration of any quantity, either scalar or vector, line integration A to B, it can be written as line integration A to P plus P to A. This is A to P plus P to B. So we can in this way we can divide the line integrals into a smaller segment for our benefit. Okay, for our benefit we can define into not two segment but into n smaller number of segment. Okay, which was also clear in the definition which I given in the very first part. Okay, so line integration between 2 points can be divided into any subdivision. There is no limit, you can do any subdivision as much as you want. So this is property number 1 of a line integral. Property 1, you can prove it by yourself, it's not so hard to prove. Okay, so second property will be involving the dot product of line integral. What we can prove that A to B A dot dr will be equal to the negative of B to A dot dr. Okay, so for vector line integration this property is satisfied. A to B A dot dr will be equal to, if we reverse the line integral from B to A, that value will be equal to exactly the negative amount, the negative of the first integral. Okay, so this property is also satisfied for this kind of line integral. A cross dr will be equal to, so line integration A to B A cross dr is equal to minus B to A cross dr. It is similar to the expression that we have found earlier. Okay, now let's do some problems of involving line integral. Okay, the first problem is given as below. Evaluate the line integration of A dot dr, where A vector is equal to x plus y into I cap plus y minus x into j cap. So basically this is a two-dimensional vector, it is in the xy plane. Okay, and you are asked to evaluate line integral across three root 1, root 2 and root 3. Okay, root 1 is from the point 1 1 to 4 2 through the line y square is equal to x, so this line, and root 2 is from point 1 1 to 4 2 through the point x is equal to twice u square plus u plus 1, y is equal to 1 plus u square, where u is nothing but a parameter of x and y. Okay, so basically you are asked to do the line integral along this line. Okay, and the third line, the part of the problem is that you have to do the line integration from 1 1 to 4 2 along this path from this point to this point. So this is 1 1 and therefore it will be 4 1. Okay, then 4 1 to 4 2. So first you have to come from this point to this point along this route, and then 4 1 to 4 2 along that route. Okay, so there are three paths available and we are asked to determine the value of this line integral along this three path. Okay, so how to solve it? The solution. Okay, given first let's evaluate A dot dr. A dot dr will be x plus y into I cap plus y minus x into j cap, dot product of dx into I cap plus dy into j cap. Since this is a two-dimensional vector, so the value will be x plus y into dx plus y minus x into dy. Okay, and we are given that y square is equal to x. Okay, so let's do the differentiation with respect to x. Then it will be, this will be 1, so twice y dy by dx is equal to 1, so twice y dy will be equal to dx. So this is root 1. This is from this point to this point through this through the root y square is equal to x. Okay, so now what we are going to put, we are going to put the value of dx here. basically the idea is to replace x or y with respect to each other. I mean, we want an expression which only involves either x or either y. Okay, so that we have to that we have to do here. Okay, so say this is expression 1 and this is expression 2. Okay, so let me in expression 1 replace y x with respect to y. Okay, so what we will find then, so x plus y will be equal to, say, a dot dr is equal to x plus y. X is nothing but y square, therefore y square plus y. In the place of dx, what we will write? Twice y into dy, twice y into dy. Okay, plus y minus, in the place of x you will write y square into dy. Okay, so what we have found finally, twice y cube into dy plus twice y square into dy plus y dy minus y square dy. Okay, so finally the expression comes as dy. So this will be this part and this part. When we will do the calculation, it will give us y square dy plus y dy. Okay, so a dot dr we have expressed it with respect to y only. Okay, now you have to see what is the change in the coordinate with respect to y. Here the y coordinate is 1 and y coordinate is 2. We don't have to worry about the x coordinate changes because anyway we have replaced x with y here. Okay, so by doing the integration from this point to this point means we have to change the value of y, and lower limit of y will be equal to 1 and upper limit of y will be equal to 2. Okay, so let's do that. So a dot dr integration. So as I have told you, the lower limit, because we are given this plot like this, 1 1 to what was the other point? 4 2. Okay, this was 1. Okay, so we have to put from y is equal to 1 to 2, therefore 1 to 2. First term was twice y cube into dy. The second term was y square into dy, 1 to 2 y square into dy, plus third term was y into dy, 1 to 2 y into dy. Okay, so what we will get? 2 y to the power 4 by 4 2 1 plus y cube by 3 2 1 plus y square by 2 2 1. Okay, so half, this is y to the power 4, that means 2 to the power 4 minus 1 to the power 4 plus 1 by 3, 2 cube minus 1 cube plus half, 2 square minus 1 square. Okay, so 1 by 2, 2 to the power 4 is 16, 16 minus 1, that will be 15, plus 1 by 3, this is 8 minus 1, this will be 7, plus 1 by 2, this is 4 minus 1, that will be 3. Okay, so if we do it, then the final answer will be say what is the LCM? This is 6, so 45 plus 14 plus 9, so it will be how much? 6, this is 45 plus 14 59, and this is 68, so 11 2 by 6, that is 11 1 by 3, so that is our answer. Okay, so the value of line integration from 1 1 to 4 2 along the path y is equal to x square, or what was the path? Y square is equal to x is equal to 11 1 by 3. So this is the first integral which we have found. Okay, and now let's proceed towards the second problem. In the second problem, what we are asked, we are again asks to find the value of the integration, but from 1 1 to again 4 2. But now what we have to now the value of x and y are given with respect to other parameter u. So x was given as twice u square plus u plus 1, and y was given as 1 plus u square. Okay, and again we would write a dot dr. The value of a dot dr was how much? X plus y into dx plus next was y minus x into dy. Okay, and we are given x and y as a parameter of u. So basically what we have to do, we have to just put the value of u with respect to x and x and y. Thus we have to replace x with respect to u and y with respect to u, and as you can see, then also the value of the coordinate 1 1 and 4 2 will changes, because after all we are going to replace it with respect to u. What will be the value of u with respect to x and y, that we have to determine. Okay. So first let's put x and so first let's find out the value of dx. So x is equal to twice u square plus u plus 1. Therefore dx by say with respect to du will get 2 into 2u, okay, plus 1. So dx is equal to 4u plus 1 into d4. That is the value of dx. Okay, and y is given as y is equal to 1 plus u square. So dy by du is equal to twice u. So dy is equal to twice u into du. Okay. Now what we are going to do, we are going to replace this value of dx and dy in the expression. Also we are going to replace x and y there, and finally we'll change the limit from 1 1 to 4 2. We have to find what will be the value of the u with respect to this value. Okay, so let's do it. So a dot dr finally becomes x plus y dx. So x value of x is equal to twice u square plus u plus 1 plus y, and y value is 1 plus u square as it is given, and the value of dx as we have found, and the value of dx is equal to 4u plus 1 into du plus then y minus x. Y value is 1 plus u square, and x value is minus twice u square minus 1 minus y. Okay, and the value of dy was twice u into du. Okay, so this expression will come as so 3u square plus u plus 2 into du plus this value will come as 1 cancel out, then so this will be all minus. Yeah, so this will be minus u square plus u square plus 1 sorry u square plus u into twice u du, and this value was there was 4u plus 1. Okay, so we are just doing nothing but the simplification. Okay, so if you put du, so this value is equal to so first you have to multiply this factor with this, then this factor with 1. Okay, so for that will be 12 u cube plus 4u square plus 8u plus 3u square plus u plus 2. Okay, then minus, we can take both these two terms inside the we can combine these two terms, because after all now the parameters are changing with respect to u. Okay, so this will be minus 2 u cube minus 2 u squared into du. So finally what we will get, du. So you see 12 u cube, 2 u cube, that is 10 u cube. Now this 4 u square, 3 u square, 2 u square, but this is minus, so this is 4 plus 3 7, so minus 5 u square. Okay, now 8 u, so 9 u minus 9 u, this is plus 2 into du. So this is our final expression. Okay, so this is finally we have obtained after doing all this calculation. Now we have to find the value of u when you see we are asked to do the integration from 1 1 to 4 2, right? This integration we have to do, and this is the value of x, this is the value of y. Similarly, this is value of x, this is value of y. Okay, now here we have expressed it with respect to u. So now basically it will be our job to express 1 1 or xy with respect to u, and again xy with respect to u, coordinate of the point u. Rather than the coordinate of point xy, we have to use the coordinate of point u. Now how can we find it? Okay, so for that we have to solve this equation. For example, twice x is equal to how much? Twice u square plus u plus 1. So it will give us 1. Okay, similarly 1 plus u square is equal to 1. So we have to find a value of u which satisfy this equation simultaneously. So from here you can see u square is equal to 0 from this equation, so u have to be 0. So if you plug in 0 here, then as you can see this equation is automatically satisfied. So for the point 1 1, the value of y will be equal to 0. This way we can find out the value of u. Okay, similarly let me do it for this point also. In this expression, 1 plus u square is equal to 2, because y we know 1 plus u square, right? And the value of y in this expression is equal to 2. Therefore 1 plus u square is equal to 2. Then u is equal to 1 u square. Therefore u is equal to plus minus 1. Now we have to plug in this value of u in the expression of x, so that it satisfies x is equal to 4. For example, x is equal to how much? Twice u square plus u plus 1. So we have two choices of u. Either u is equal to plus 1 or u is equal to minus 1. If we put u is equal to plus 1, then what we will find? What value of x we will find? 1 square plus 1 plus 1, that is 4, which is exactly the value of x. Okay, so for the coordinate x and y equal to 4 2, the value of y is equal to 1. Okay, so in this case, and in this integration, the lower limit will be equal to 0 and the upper limit will be equal to 1. Okay, then both the condition will be satisfied simultaneously. Okay, this way we can change the dependence of x and y to in the parameter u. Okay, so now our job has become really easy. We have to just do this integration by evaluating, by changing by with the lower limit of u as equal to 0 and upper limit of u as equal to 1. Okay, so it gives us 0 to 1, and then 10 u cube, then plus 5u square. Earlier there was a mistake, it should be plus instead of minus 1, plus 9u plus 2 into du. That's all. Okay, so 10, so 0 to 1 y cube into du plus 5 u square into du 0 to 1 plus 9 u du again 0 to 1 plus 2 0 to 1 du. Okay, so it will finally give us y to the power 4 by 4 1 0 plus 5 u cube by 3 1 0, upper limit is 1, lower limit is 0, plus 9 u square divided by 2 1 0 plus 2, upper limit is here 1, lower limit is 0. Okay, so finally you will get 1 by 4 plus 5 into 1 by 3, lower limit is 0 in both cases, so I don't have to consider, plus 9 1 by 2 plus 2. Okay, so if you do this calculation, finally what you will get, this will be 12, so this is 30 plus 20 plus 54 plus 24, so 128 divided by 12, so this gives 12 and 8, so 10, so this will be 2, this is 3, so this is our final answer, 10 2 by 3, 10 into 2 by 3, this will be our final answer. Okay, so in this way we can do the line integral when x and y are expressed as parameter. Okay, so let me proceed to the final problem, which is I think the most important one, because here you need proper understanding of line integration. Okay, so the problem was basically we have to find it along this path 1 1 2 4 1, then 4 1 2, we have to go to 4 2, I guess, yeah, 4 2. Okay, and in this line it was given that y is equal to 1, as you can see, 1 here y coordinate is 1 and again y coordinate is 1, and in this line x is equal to y. Okay, so this is two paths are given. We need to do the line integration first from 1 1 to 4 1 and then from 4 1 to 4 2. Okay, so let me first do the first part 1. This is problem 3 of the original problem. Part 1, we are going to do 1 1 2 4 1. Okay, now here you can see y value is constant here for the first thing, for the first point y is equal to 1, and for the second point y is also equal to 1, so there is no variation of dy, so dy is equal to 0 here. Okay, and we know that a dot dr from the calculation which I have done earlier, its value was how much? X plus y into dx plus y minus x into dy. Okay, so dy is equal to 0, so obviously this term does not exist, so we have to put x plus and here you see y is equal to 1. Okay, so because here y coordinate does not change, 1 1 to 4 1, so along this line y is equal to 1, so we are going to put y is equal to 1 here into dx, so it's the variation of dx, and the upper limit of x is equal to 1 and lower limit of x is equal to 1 and the upper limit of x is equal to 4. That means x varies from 1 to 4, so here the lower limit will be 1 and the upper limit will be 4. Okay, so this is like x square divided by 2 4 1 plus dx 1 4. Okay, so how much we will find? 4 square divided by 2 minus 1 square divided by 2 plus 4 minus 1. Okay, so this value 16 divided by 2 will be 8 minus half plus 3. Okay, 8 minus half plus 3. So if we do the calculation, how much value it will come? 16 minus 1 plus 6, right? This is 6. Okay, So this value will be 21 divided by 2, so 10 1 by 2, right? So this is the value of the first part. Okay, now part 2, we have to consider from 4 1 to 4 2. Now here you can see in this line, along the line x is equal to y, the x coordinate is 4 and also the final point x coordinate is 4. Therefore the variation of x for this line, that is the value of dx, variation of x is represented by dx. Dx is equal to 0. So we don't have to consider this part here. We only have to consider y minus x is equal to dy. Okay, we have to only consider this below. Okay, and also as you can see here, the value of x is equal to 4. Okay, and the y changes from 1 to 2. Okay, so we have to keep in mind that thing also. So part 2, we don't have to consider this part because the x coordinate does not changes its value. X is equal to here 4. Okay, so dx is equal to 0 basically. So part 2, if we write c a dot dr will be equal to how much? It will be y minus, you see here x is equal to how much? X is equal to 4 basically, so we have to put x is equal to 4 here into dy, right? And dy changes from which point to which point? 1 to 2. Dy changes from 1 to 2. Here only the value of y changes, x doesn't change, and this part is represented by x is equal to y. So because x value does not change here, so basically x is equal to y is the part we have given. Okay, so now what we can write it, 1 to 2 y into dy minus 4 1 to 2 dy. Okay, so first part will give us y square over 2, upper limit is 2, lower limit is 1, minus 4 2 minus 1. Okay, so this is 4 by 2 minus half. If we just put the value of upper limit and lower limit, minus 4. Okay, so 2 minus 4 minus half. So this will give us value. If we do it, it will give minus 2 half. Okay, the first integration value is 10 half, and second integration minus 2 half. So from this part to this part, the value of a dot dr is equal to 10 1 by 2, and from this point to this point, the value is minus 2 1 by 2. So from 1 1 to 4 2, along this two path, we just have to we just have to add up these two values. Okay, so final result become, so finally c dot a dot dr along this the whole path from 1 1 to 4 2 is given now 10 half minus 2 half. Okay, so its value will be equal to. Okay, so in this way we can do